Now let's talk a little bit about how the Earth moves around the sun through space. So the Earth is always moving in two ways. The Earth is always rotating, which means spinning on its axis or spinning around, right? This rotation is what gives us day and night, right? If this flashlight's the sun, where the sun is shining is day, and as the Earth rotates, one part goes into night, as another spot comes into day. That's North America, and as North America rotates away, turns to night, and now it's day in Africa and Europe, and so on and so on. So Earth is always rotating. That gives us day and night. But Earth is also revolving around the sun. Revolving means if you're the sun, then the Earth would be doing this around you, right? Going around you in a circle, right? So that is revolving. So the Earth is moving two ways. It is rotating to get day and night, and it is revolving. And this revolution, this revolving around the sun, is partially responsible for giving us seasons. Another reason we have seasons, like summer, winter, fall, spring, is because of Earth tilt. We'll talk more about that in a different unit. But really, this movement, this revolving around the sun, makes us see different stars throughout the year, right? Because we are literally moving through space to different parts of our solar system. Now, Earth rotates, remember, spins around itself. Earth rotates once per day or once every 24 hours. So Earth rotates once every 24 hours. So if we start here in India and we rotate, there's India again. It has been one day or 24 hours here in India. Now, if we're talking revolution, remember revolution means the Earth goes around or orbits the sun. So as the Earth, if we put a mark on the Earth and traced its path, this is what the path would look like. Comes in front of the sun, spins around behind it, goes behind the sun, comes around the side, and comes back to the beginning point. When the Earth reaches the point that it started at, we know this has been 1 year or 365 days. So this is important because you will be tested on it. A rotation is 24 hours and makes 1 day. A revolution is 365 days and makes 1 year. Now, because of this revolution, Earth is moving into different parts of our solar system that are very far apart from each other. And because of that movement, at night, we're able to see different parts of our solar system. So what that means to us, when it's night and we look up, we're looking at stars. But if we go 6 months down the road and we go out at night and we look up again, we're not going to see those same stars. We're going to see different stars. Because if we start right here and we're looking at the night sky, we're looking at stars right here. But if we wait 6 months, we'd be about right there. And now if we go outside and look up, in this position, we're looking at these stars here. But in this position, 6 months later, we're looking at these stars here. So we're seeing different stars throughout the year because Earth revolves around the sun. And in different times of the year, it's in a different location of the solar system. And every time it's in a different location of the solar system, we're looking at a different sky, or we're looking at a different part of our galaxy and our universe. So when we're out looking up at stars, some of those stars historically have been given names. And, well, let me make a correction. all the stars have been given names, but some of them, historically, have been grouped together to form like a picture or an image or resemble something, and that group of stars has been given a name. So a group of stars that forms a recognizable shape or picture or pattern is called a constellation. And humans have studied these constellations for hundreds and hundreds, if not thousands and thousands of years. They've been looking at them for as long as they've been looking up. Why that's important to us is because if you'll look here and here, these are, I'll let you come look a little closer. I put some examples of constellations up here. So this constellation is Virgo, and Virgo is able to be seen in May. Now, if we come over here, this constellation is Ursa Major, and Ursa Major is visible mostly in May, but Ursa Major has a very common, you see these bright stars right here? Ursa Major has a very common, well-known constellation called the Big Dipper. So the Big Dipper is actually a part of Ursa Major. Ursa Major is this whole group of stars. And Ursa Major actually is the picture of a bear, and the Big Dipper is a part of that. So there are, if we keep going around the room, you can see there are, you'll see a few of them. See all these little squares. There's 3. If we come around here, there's 3 yellow ones. If we come around here, there's 3 pink ones. And we come around here, we're back to our green ones. So these constellations, these pictures of constellations, are up there to help us experience what it's like for Earth to revolve around the sun. Okay? So I'm going to make a small adjustment here. Let's move some stuff. All right. So I hope we don't get motion sick, but we're going to move around a little bit. So let's say, what's today? Today is February 23rd. So let's go find February. Here we go. Right up top here. All right. So February says that Gemini is going to be the constellation. What that means is it's February. If we go outside and we look up high in the sky, we should be able to see Gemini, this constellation, in the sky. But that's not the only one we can see, because if you can tell, here's a constellation on that side, and there's another constellation. Where is it? Way over there, another one. So even though I'm here under Gemini, this is not the only constellation I can see. I can also come over this way, and if I look way over on one horizon, I will see Taurus, that was visible in January. And from Gemini, if I go the other way to the other horizon, I will be able to see Cancer, which is in March. So that's if I'm in February. But now, if Earth moves, remember, if we are moving around the sun, called revolving, as Earth moves around the sun, we will move along, and in March, now Cancer is the one that's high up in the sky. But is that the only one we can see? Absolutely not. We can still see Gemini way over on the edge, on the horizon of one, on one horizon. And if we go to the other horizon, we can see another constellation, which is going to be back to Ursa Major, over on the other horizon. So as we move around through space, as we revolve around the sun, we are looking at different constellations at different times in the year. Let's fast forward a little bit. Let's say we're revolving around the sun, we're revolving around the sun, we're revolving around the sun, And let's stop right here. Let's say now it's July. In July, we'll look up in the sky and we will see Scorpio right above us. If we look to one horizon, we will see Ursa Minor, the Little Dipper. And if we look over to the other horizon, we will see Sagittarius. Sagittarius is actually my zodiac sign. So what we're learning is, right, and we can keep going around. Okay, so constellation, let's keep going. As we get into fall in September, we will be able to see Copernicus or Capricorn. Remember, and we'll still see that constellation over there. We'll still see our next one over there. And now Earth is revolving again. We're moving forward another month. Now we have Aquarius high in the sky in October. We can still see our last constellation, Capricorn. We can see our next constellation down on the horizon. And once again, as we revolve, that constellation that was way down on the horizon, now it's high up in the sky. Orion. This one's actually really easy to see. You can see it almost all the time during the year. It's easy to tell because look for 3 bright stars right in a row. That's Orion's belt, and that's the middle of his constellation. He also has a hunting dog constellation. That's pretty cool to find too. Orion's hunting dog. I forgot its name. So now that Earth has moved through space, here we are looking at Orion. We can still see the constellation from last month. We can see the constellation that would be coming up next month. You can see it right here. And once again, Earth is revolving and we're moving around and Earth is going. And now Earth can see Aries. On one horizon, we could still see the constellation we just left, Orion, over here. And we could see the constellation that'll be coming up next month, right here, which would be Taurus. Right? And when Taurus is high in the sky, we can see that one and we can see our next one. And this process goes on and on and on. The point you need to remember is that Earth moves around the sun, and that movement is called a revolution. One revolution lasts 365 days or 1 year. Now, what I hope you realized here, if we were to go around again for another year, right? Let's go back to July. If we were to go back to July, what is the constellation still in July? It is still Scorpio. It's the same constellation, the same stars that were there last July. If we go to next July, guess what constellation is going to be there? It's going to be Scorpio again. If we're in April 2020, April 2021, April 2022, April 2023, April 2024, April 1901, April 1642. Doesn't matter what year we're talking about. In April, what constellation is in the sky? It's always going to be Ursa Major. Why? Because stars don't move. Ever. Ever. And that's what you need to know. Stars do not move. This sun is always going to be right here in the center of our orbit. All the stars through the universe, all the stars that make constellations, all the stars that have other planets circling around them in different systems or different galaxies, all of them never, ever move. The only things that move are us planets. So the reason, as we revolve around Earth, the reason we see different stars at different months and different seasons is not because these stars move. It's because we move. And at different times of the year, we're seeing different sections. At different times of the year, we're seeing different sections of our galaxy, different sections of our universe. Those sections have different stars. So it might look like the stars are moving, but the stars are not because they never ever do. Earth moves. Planets move. That's why we see other things. Or that's why we're seeing different constellations around the year. So that is it for today's Up in the Sky lesson.